Okay, so today I thought we would build on what we started last week, but instead of importing Rhino geometry that we've drawn first in Rhino, we'll start this file from scratch using only Grasshopper to prepare a roof form with some double curvature and take it apart and panel it in a similar way that we did before, but we'll add a couple of new tools to the tutorial this time. So as you'll see, I'm in inches here. This is just going to be a not to scale kind of model, and I'm just going to develop the project as we move forward using these units. But of course, again, anything that you model in Grasshopper, the units that you plug in will be the units that are set in the Rhino file. So if you want to match mine perfectly, inches will be a good place to start. Okay, so I'm going to start this file with just a single point. So I'm going to go over to Vector and go over to the Point tab and grab my Construct Point component. And let me just turn on my full names for you guys. Okay, so that's going to draw a point, as you can see, at the origin. And everything is going to start from here. So we'll build up this entire thing from scratch. Then I'm going to draw up some construction lines. And I'm going to start with a rectangle. So I'm going to go over to Curve, Primitive, Rectangle. And I'm just going to go ahead and plug in that point into my plane input here. And take a look at what we need here. We're going to need a domain between something and something for the x and y. If the number that you put in here is positive, it's going to draw a rectangle in the positive x and y direction, which is what we're going to do in this case. But you have the option to center that or justify that rectangle from a point however you like. So I'm going to grab a panel. So I'm going to go to the Parameters tab, grab this little yellow panel here, and I'll type in my x dimension is going to be 50, and I'll copy and paste that and make this one 25 so that it's a rectangle of those unit dimensions. Okay, so 50 into the x and 25 into the y. You can see now that I've got a rectangle that's drawn nicely into my grid here. Next thing I'm going to do is find the corner points, and I'm going to turn that preview off. There's a few different ways to do this. A quick way to do it is to just head over to Curve and go to Analysis and look for the discontinuities in the polyline. So in this case, I'll just click the discontinuity component, grab that, and plug in my rectangle into that component. And what I'm going to find is the 4 corner points. That's where the continuous rectangle as a curve or as a curve object gets broken down. So that's where it changes direction. It'll be a discontinuous moment, and it'll put a point at that moment. You can turn the rectangle on or off as you like. I'm going to turn mine off because as I go, I want to turn off the previous step just so I can keep myself organized. Okay, the next thing I need to do is figure out what order that these points are in. So I'm going to go to Display up top here and grab the point list. And I'm just going to plug that in. I'm going to turn the points off just for a second and increase the size of my points here to something like that. And now on screen, as you can see, I've got just some numbers that are on in the Rhino world here. And that's going to tell me the order of those points, so I know which ones to connect for the next step. So these are referring to the order of the points, and the index is the actual number. So an index is just basically a signifier for where each point is listed in the order of points that comes out of this component here. And everything in Grasshopper is 0 indexed. So the first item is always 0. Okay, so we'll head over to the Set tab. We'll start breaking these points down so that we can select them individually. We'll go to List, List Item. This is what we did last week. This should be somewhat familiar. And if you zoom in, you could add enough outputs to cover all of the data that we have. And we've got 4 values, so we're going to need 4 outputs. All right, turn off that preview. And now I know more or less how I want to start constructing this form. So I'm going to put a curve between 0 and 3. I'm going to put another curve that's identical to it between 1 and 2. And there's obviously many ways to do this. I'm going to select the catenary curve. So I'm going to go to Curve tab, Primitive, Box, and head down to, go to Spline, Curve, Spline, and catenary. And it's going to ask for the start and end point. And I know that I want to go from 0 to 3. And then the length of this is just going to need to be longer than the distance between those 2 points in order to get a curve to be drawn. All right. So I'm going to go to vector, and I'm going to try to figure out how far away those points are from one another. So, sorry, I didn't explain the component. So go to vector tab and distance under the point box. And now what we want to do is just add a little bit to that. So I'm going to go to math, the addition component, and I'm going to add a value between something and something else to this distance. So I'm going to double click in here, just type in 25 or something, and then hit the number slider button there, the box there, and you'll pop up a number slider that can range between 0 and 100. And then actually go ahead and edit that to put out floating point values so that we get a little more precision. And then I'm going to put that result into the length input of my catenary component. And by default, you're going to see a kind of what's going to look like a hanging string or a hanging chain. And what this does is it in a way assumes how a piece of string or a chain or something like that between 2 points that are fixed, and if those points move toward one another, of course the string will droop under its own weight using gravity as a force. We can flip the direction of gravity simply by putting in a positive z vector. So what we're going to do is go to vector. I think it's in, nope. Where is it? I guess it's in vector. Yeah, vector, vector, and then positive z. So we'll just plug in that as a positive z and change the default setting from negative to positive, basically. And now we now have a nice parameter here, a numerical input that we can use to change the height of that arc. Well, it's not necessarily. It's a catenary curve. I'm going to change mine to something like 10.5 for now, and leave that as is, and we'll keep going. And I want to draw one more. So what I'm going to do is just copy and paste this component here, the catenary component, and put it over here. And because we know that these sets of points are the same distance apart from one another, we can reuse the data that we used over here. If for whatever reason you've got a different shape and plan, you'd have to remeasure the distance between the 2 points that we're going to connect. But because it's the same, because it's coming from a square or a rectangle, we can just go ahead and just change the inputs into point A and point B. And that we know is going to be 1 and 2. So we can go 1 and 2. Okay, and now we've got, I'm going to just organize, and now we've got a single slider that changes the height of 2 things at once. And how I like to work, I like to make sure that my numeric inputs are as few as possible. I like to make sure that I'm not having to go ahead and change too many things when I make changes to this file. Keeps things a little bit simpler when it comes to the use of it and making changes later. The last thing I want to do to set up my construction here before I build a surface is to put a smaller arc somewhere in the middle. I want this thing to appear like a saddle. So let's work on a different way of doing that. Instead of the catenary, I'll show you how to use an arc component. And but to place that arc somewhere in space, we've got to tell the computer where to put it. So we need to set up some construction for that. So let's draw a couple of lines between 0 and 1 and 3 and 2. Okay. And remember that the order of the inputs is going to determine the direction of the curve. We'll get to that in a second. So let's go over to curve, line, And now I want to connect 0, which is the I output here, into the first point, and then the endpoint is going to be 1. So there's my first construction line, and grab another line component and go ahead and put in 3 into my start point and then 2 into my endpoint here. So now both of those lines have been drawn from this side that way in the positive x direction. So they have the same direction. Okay, what we want to do now is find a midpoint or some point along the length of that. So I'll go over to curve analysis. A couple different ways to do this. The easy way, the quick way, is to just grab this point on curve component. You can find it up here at the top or also down here on the left. And you can go ahead and plug the line input into there, and then you hold shift as you do this, and input both lines into the same component. So now we've got two pieces of data that is each line is coming into the same component. It'll do the it'll find the midpoint along each one of those points for you independently. So now as I make changes to this little like slider button here, you'll see that the little point moves back and forth, and because it's because the curve that we drew, or the line here is drawn parametrically, it can be described between 0 and 1. So I can describe its any position along that point between 0 and 1, which is how it's parameterized. Sometimes if you bring in work from Rhino, that's not the case, and this number will not work. In that case, we just simply reparameterize the line, and I won't get into that. That's a simple input, but just to kind of make note of it. This component's kind of cool because you can kind of work with some presets to position exactly that point in space. I'm going to leave it at 0.5 for now as we move forward. Okay, and now because I want to draw an arc between these 2 points, I need to separate them, and I also need to I want to also bring the points inward a little bit so that in plan this thing takes kind of an hourglass shape. So we can do kind of like what we've been doing over here. You know, we can use this list component to just separate out parts out of a list. So we go back to set list. Sorry, where is it? List item. There we go. Yeah. All right, and then we can zoom in, hit plus, and there's my 2 outputs. And again, just out of habit, I like to turn off previous previews so that I don't have too many things overlapping. I'm then going to go to curve, draw a line in between these 2 points, like this. And this is another construction line that I'll use to position 2 new points in this direction as the start and end point of the next arc. And here I'll show you a different way to find those points along this curve. So we'll go over back to analysis under the curve tab and grab evaluate curve, which is over here midway down on the right. And go ahead and plug that line into the curve input. And let's grab a basic slider over in parameters and just pop that in. And you can see that we're doing something similar here between 0 and 1. But because we want 2 and we want them to be mirrored against one another from the center point of this line, what we can do is just simply go to math. Let's grab a subtraction in this case, and we're going to grab a panel, make my what I'm subtracting from 1 because that's the maximum value, and subtract this number from 1 to get the opposite result, which is 0.8 in this case because this is 0.2. Now we can go ahead and hold shift and plug that into parameter as well, and we're now drawing 2 points simultaneously with 1 slider. Now these are going to pass one another, but that's not a big deal because actually the way we're going to use this component is we're really never going to go probably much further than this, you know, to draw this arc. So we're in a safe zone here in terms of our solution space. Okay. All right, so let's draw ourselves that arc. We're once again going to separate out those 2 points. Go over to set, list item, pop it in and zoom in, grab another output, turn off that preview, and I think you're probably starting to get the hang of that. Just a way to develop a good habit. Now this time what I'm going to do, instead of a catenary is draw an arc, a more proper arc. So I'm going to go to curve. Where is it? Primitive and arc SED. Okay, the one over here on the left. And my start and end point are, I think, obvious here. They're coming from the 2 points we just drew. And then what we need to do is give this thing a direction, a vector direction. So what we're going to do is go to the vector tab, and we're going to go to vector and rotate, because we're going to want some control over the vector. The vector that we're going to set as our base vector is going to be the y direction, because that's the direction that this line is drawn in. This is drawn in the positive y. If that's not the case and it's off at some weird angle, you can draw a custom vector between the endpoints of that line itself. But we don't have to do that here, so we're just going to go to vector and unit y. Plug in the unit y into vector as our base. The axis that we're going to rotate this against is of course the x. So we'll head back over to the same place to grab the unit x as our axis. Okay. And then I'm going to right click on the angle input here and click degrees. This is just easier to work with in my mind. It turns radians into degrees as an input. So now it's looking for an angle input, which is in degrees. And for that, we can double click in here again and just type in something like 50, grab the slider that comes out of there, and we can plug that direct into the angle input, and then go ahead and plug that vector into the direction input of the arc component that we just grabbed, and you can play with the results. So here we've got some control over the shape of that arc. I'm going to leave mine at 70 degrees. And I'm also going to go back and change the location of its start and end point to something a little bit closer, something maybe like 1.7. Yeah. So now I've got 3 arcs, 2 of them drawn as catenaries, and 1 of them drawn as a semicircle. All right, the next step then is to just simply loft these together to form my surface. Okay, so let's go over to Surface, Freeform Loft, and you could also do a sweep here if you wanted to draw, if you wanted to draw another curve between these 3 points down in plan. I don't think it's necessary. The loft will do just fine here, especially if we rebuild it. But here is where we need to organize a little bit before we start plugging stuff into this, because it's going to need to be in order. So the curves that you select, similar to Rhino, are going to have to be in a kind of sequence that makes sense. So to organize that nicely, what I like to do is go to Set, Tree, and you can merge the curves together in the order that you like. So this is going to be the one closest to the 0, 0 is going to be my data 1. The second one is going to be the arc, of course, because that's next in line. And then the third one will be my last catenary at the end there. And now, if we ever make any changes, we can just simply replace one of these inputs really quickly without having to disconnect everything from the loft. So I'm going to just kind of bring this stuff over along for the ride here. And I'm going to plug those in. And it looks like what we've got is a curve now that needs to be flipped, right? So the direction of one of these catenaries is, for whatever reason, in the opposite direction as the other. And so what we want to do then is, and here's where it gets helpful again to disconnect only one thing from the list. So we'll go ahead and disconnect this one. And we'll head back. We'll go to curve. And I believe it's in utility where we should be able to flip the direction of that curve. Let me see where it is here. There it is, right up at the top. So flip curve. So we're going to flip this thing around, and then we're going to re-input that result into the third input of my merge, thereby fixing the issue. Okay. And my loft now is pretty good, but it is a little bit overly detailed, I would say. It's got a lot of ISOs going in one direction. So what I want to do is go over to options, and just kind of clean this up a little bit. We'll go to options, loft options. You can leave normal alone and go to none, this little drop down here, and change none to rebuild. And then let's maybe do a 50-point count. So rebuild with 50 points and commit those changes. And what you can see is that we've got a little bit of probably a looser approximation of a surface through these arcs, but a really clean surface that we can start with into the next step when we start panelizing. And now you're welcome to go and, play around a little bit with some of the other parameters. Of course, if you change the width, it will update for you, or sorry, that's the length. So everything, earlier on will affect what's downstream, what's connected to it. Remember, what this really is doing is just developing a list of dependencies. So one thing is dependent on the next, and as you go, you make sure that those dependencies create the kind of solution space that you're looking for. Solution space meaning the amount of control you have over the final outcome. I can change this to give it some different shape in the middle. Now, of course, there are limits to whether or not, it does start to break a little bit. The loft starts to get really weird in some areas, and that is to be expected. I mean, there are limitations to everything. And here, because I never really intended to do something like that anyhow, this kind of failure is not important to me. But to have the ability to go from, let's say, a third to a half might be interesting. Of course, all this stuff will also affect the final outcome. I think I had that at 0.17, kind of a nice sweet spot. Okay. And of course, you can change the height here. I think you get the idea. Cool. Okay, so let's keep moving and let's start panelizing this thing. So here's where we're going to do a little bit of review from last week, just to kind of, cover that once again. But we're going to do something slightly different in the end by the time we're done here. Okay, so let's break the surface down into different parts, different panels. So we'll go to Surface, Utilities, Isotrim. Plug that in. We know we need a domain to break this down. We'll go to Math, Domain, all the way to the bottom, divide domain squared, and plug that in like so. So loft and domain, segment into domain on the other side. Now, here is where we should start turning off some old previews. So I'm going to turn off that old loft so that I don't get confused about what I'm looking at. I want to also grab another parameter, a couple of these. I'm going to make one of them 10 and plug that into my U. And then I'll change this one to something like 40 to have a bunch more in the V direction. Oh, actually, that is the opposite of what I was expecting. So I'm going to swap these like that. And because it's hard to know which one is the V and which one is the U. And sometimes actually it's not what you want. So I'm going to talk about that in just a second. So let's figure out, first of all, what order that these panels are in. Because if I'm going to take these panels, planarize them, and expect them to shed water, let's say that we want to shingle these one over the top of the next. If we want that to shed water, because this is an arch, we have a topmost condition here, and we want the water to always go outward, never pool up in the middle. Or, of course, you don't want shingles to be facing the sky, you want them to be facing downward. So what we can do in this case is split the panels in half. So if this is a list that's single, we can split it into two different lists, separating this side versus that side, and that will make it easier for us to determine which side gets the shingled side. So if all these squares are oriented the same, the side on this side of this edge of this side of the surface is going to shingle this way, but that same edge faces upward on the other side of the arc, so we want to swap that direction. So it's easier to sometimes separate out the data sets without having to fuss with that a little bit later on. So it depends on how you want to do it, but sometimes it's good to separate out the geometry now before we get into adding more complexity, to the system. So let's first of all figure out what direction all this is in, and a cheap and easy way to do that is to go over to Set, same one that we always do, the list item. Let's kind of see where these are, and I'm just going to zoom in and just kind of output a few of them. And you can see that looks like they're organized in the short direction. So it's going to be 0 through whatever, and then it'll start again over here and keep going. So in terms of their ordering, it's going in that direction, which could make it a little bit trickier to separate out the panels into two halves along the long axis. I can show you a number of ways of doing this, but the way that I've selected to do it for this tutorial is to actually change the U and V directions on the surface so that we're ordering the panels in this direction as opposed to that direction. Okay. This will make a little bit more sense in just a minute. So what we're going to do is head over to Math, and we're gonna make a custom component for this, because unfortunately the way to swap U and V values, there is no component for that. There's no single component for that, I should say, in Grasshopper. So what we can do is make a custom component by just by scripting it. In this case, just using a basic script. So we can use a vb.net. So we're going to go over to Math, Script, and grab this little VB component here. And we have to just modify this in order to get the output that we want. So what we're going to do is zoom in and delete the Y, and right-click on the X, change its name up at the top here to capital S, which will be surface. Right-click on the A, change that to capital T, and then double-click into the onto the VB symbol there, and you should see this thing pop up, which will be where you can start typing in some code in order to get the computer to act like you would like. So what we're going to do is just basically call a command from Rhino. Again, that doesn't exist in a single component in Grasshopper at the moment. So under the area that says private sub here, just type in, and this is going to be pretty simple. So we're going to just type in T equals S dot transpose, and it might come up. Doesn't look like it. That's okay. And you can just click away somewhere so that it just says T equals S dot transpose. And you can just click OK. And now if we plug in our S input, oops, something went wrong here. 1 second. Right, there's one thing that I forgot to do, which is to right-click on the S here, and we have to give it a type hint so that it's looking for a certain kind of data input. So we just, it's looking for a surface, but right now it doesn't know that, so we can just go down to type hint in surface, and now that should go gray, and we're drawing a new surface here. So now if we plug in and replace that loft into both of these inputs, and let's go ahead and turn off the preview for that VB script, what we should be seeing now is my panels organized from this component in the opposite direction. So what we've done is we've just flipped basically the U and V directions, which also means that for me to draw my shingles right, I can go back and swap these again. Okay. So it's just something to be aware of when you're working, with surfaces and breaking them down. Sometimes, it's a benefit to organize the parts that are coming off the surface in the way that you would like, and every now and then Grasshopper's going to make a selection as to where to put the U and V's, and it depends on how it's drawn, but we can change that by just with a little custom component here. This also opens up a conversation over how much more control you actually have over Grasshopper, and as you get more comfortable, you can start creating custom components of your own. Okay, now we want to break it into two different halves. So we've got 400 surfaces coming out of here, and that's a function of the inputs that are coming into my U and V. Okay, so 10 times 40. I'd like to introduce you to the partition command, which is quite useful. So I'm going to go to set list partition. Grab that, and the first thing I need though is to find out how many of these I have. So I'm going to go to set list and then list length right here on the left, list length, and this will tell me how many items I have. And then I can go to math divide, or math division I should say, and just divide that by 2 because they're ordered in the right direction. And because I want to split this into 2 halves, I can just divide this entire thing by 2. And that's going to end up being my size. And the list itself is these surfaces. Okay, so I'm going to get that out of the way and plug that in. And you're not going to see anything happen here, but if you overlay, if you just put the mouse over the output, you're going to see that it lists chunks now we have. Those 400 items have been broken into 2 lists of 200. And let's find a way to access each one of these lists. So we're going to go to Set, Tree, Explode Tree. And go ahead and turn off the preview for our original ISO trim over here. And here's the sets of 200. And I can show you, if we turn that component off and just have a look, go to parameters, grab the surface parameter and just have a look at one side at a time, you can see that it's organized in the way that we like. So if I didn't do the transpose, it'll organize this differently. So we should be able to do this. Yeah, this should be no problem. You don't have to follow along, but just wanted to show you so now it's broken down into the opposite half. But the transpose will reorganize that for us nicely. Okay. And we're going to, just for the sake of keeping things clear, we're just going to work on one side at a time, knowing that we can always copy and paste a block of code here to also affect this set of items, but we're going to have to make a couple changes just so that they shingle in the right direction. So let's go ahead and get this started. This is going to be a process, again, similar to what we did before. I want to first make these planar and get them to sit in space as close to the surface as possible, but still be a flat panel. So if they're glass or if they're wood or something like that, they're easier to make and easier to construct. So the first thing I'm going to do is just go to Surface. I'm going to deconstruct all of these surfaces, and I'm just going to turn that off because we're going to see it again anyway. Okay, let me expand that a little bit. Okay, and now I'm going to grab a couple components from the Surface tab analysis box. I'm going to grab the area component. We're going to look for an approximation of the centroid or the center point. And then I'm going to go to analysis again and grab two more components, which is the surface closest point and the evaluate surface component. This point we're going to bring as close as we can to the surface itself. And I'm going to turn that preview off. And then we're going to use the output of the U and V to determine where that plane should be drawn. And let me increase my plane size so you can see it a little bit better. There we go. And this is going to be basically the direction or the orientation in space that each of the panels will rest against. Okay, and what we're going to need to do is we're going to need to graft this. So I'm going to go to Set, over into Tree, Graft, and go ahead and plug the frame into there and turn off that preview. And now we're going to do the project, which you might recall from last time. So I'm just going to go to transform and affine and find the project onto plane component as such. The geometry that we're projecting is the vertices, and the plane is the plane we just drew. Now you can turn that plane off now. If we zoom in, you'll see that the points are misaligned, and that's because now they're resting against a plane in space that no longer connects all the panels together, but flattens them out. And as a quick test, before we do any shingling, we can just draw a polyline through. So I'm going to go to Curve, Spline, Polyline, plug the geometry in like that, and I'm going to just go ahead and I'm going to right click on the closed input here, set that Boolean to true. And then I'm going to go to Surface just to make sure that everything is actually planar. I'm going to draw, so I'm going to go to Surface, Freeform, Boundary Surfaces, and draw a surface into that polyline to make sure that they're planar. This component will not work. It'll go orange or red if the polyline itself that you're giving it, or if the edges are non-planar. So this is a nice component to use for this because it guarantees that the piece is actually flat, because otherwise they just won't draw. Okay, so that's one of the early on steps of at least planarizing this saddle-like shell structure. And if we zoom in, we can see that there's little gaps in between, and we know why that is. We talked about it last week. But in order for those curved panels to go flat, they're going to have to depart from one another at their edges. And then, of course, the frame that's holding these panels on would take up that space and ensure that it's sealed from the weather conditions and so on. But there's one more thing I want to do in this file before we wrap up, which is to shingle it. And then next week, maybe what we can do is follow up with some more custom ways of working with panels on surfaces, changing the geometry, maybe adding some three-dimensionality to it, rotating them in space a little bit more, things like that. But for now, what I want to do is just kind of add an edge on this side so we can at least, build out what I think could be a nice set of shingles over this, shingled panels over this surface. Okay, so I'm just gonna put this stuff up here, and I'm gonna turn off the preview because we're gonna kind of start in a little bit of a different way. So I'm gonna go to Set, List Item, and I'm gonna just break out the 4 points that we just projected. Okay, so we've done that before, so that's just kind of zooming in, giving it enough outputs to see them all. Yeah, and then we're going to draw some lines. What I need to do is draw a couple of lines along the edges of these, along the edges of each panel that are in the downward position. So just as a way to do it by trial and error, I'm just going to go to Curve, Line, and just go ahead and plug in 0 to 1 and copy and paste that, and just go to, and then do 2 to 3. And that gives me my parallel lines along each panel in the direction facing the ground. And we're going to see if this works in the next step. And I'm going to then blend those curves together to give this panel a kind of rounded edge to it, just for fun, as a demonstration for how we could kind of start customizing the panel shape. So let's go to Spline over in the Curve tab here and look for Blend Curve at the bottom. And now it's going to ask you for 2 curves, so I'm just going to input curve A into curve B like that. Okay. Yeah, all right, so that we got kind of lucky, and it's starting to draw those curves in the upward position, which is, we know that that's not what we want, of course, because that's not going to shed water very well. We want it in the opposite direction, but at least it's drawing at least we know that the curves we drew are at least in the same direction, because otherwise, if we did say something like that, we'd end up with a bit of a mess here. So on our first shot, we got it pretty well. The only thing we need to do now is just change the inputs here. So swap those inputs, and that will turn the blending downward for us like that. And then we are going to need a top curve to finish this off as a planar panel. We're going to need the top of the panel, right? So let's draw one more line, and in this time it's going to be between, I think, 1 and 2, and that'll be the top edge. And I'll just kind of line that up nicely. And here's where we can do another merge, or maybe we can just make this, or actually we can just do a join. So it'll be easier if we just joined the curves in this case. So we can just go to Utility, Join Curves, and you can start plugging these in, holding Shift as you add more inputs. Okay, so we can start doing this. And then we can turn all that stuff off, leaving just the polyline remaining. We can grab this component from before and swap out the input to the new input, turn that back on again, and it looks like we've got some success here. We've got a set of kind of nice curved panels that shingle over the top of one another just because they've been extended along one of their axes. Okay, so now the curvature of the surface helps with the shingling, right? Because this panel is going to keep going in that direction, which is not the same as that direction. So as it goes over, it's going to create that kind of airspace or that gap in between. And you can decide on whether or not that's acceptable or whether or not it's desirable. But it's again, just an example for how we can start customizing each panel shape by just extracting its 4 corner points, redrawing the panel as we like within those corner points, and using these data trees to basically to draw a collection or a whole, basically an array of panels along a surface, because everything that we needed to do that is extracted from the surface. And because Grasshopper by default organizes those sets of points for us panel by panel, we can draw them independently of one another all at once here. So we're basically automating quite a bit of what would end up being a lot of tedious work if we had to model each one of these independently in Rhino. Yes, and now why don't you go ahead on your own and see if you could. We've got all of this stuff coming out of one of these branch outputs here, but we need to finish off the surface by doing the same thing out of the other branch. So one thing you can do is copy and paste all this code here, put it down somewhere over here, swap out the inputs so that it all comes out of this one, and then figure out how you might have to make a change over here to get the blend to go in the right direction. All right, see if you can experiment with that a little bit, and that would be interesting to see. And again, in a follow-up to this one, before we wrap up the term, we'll talk a little bit more about how we might actually start building in more custom shapes into these panels that we're extracting from the surface. But this, I think the big one here is that we not only reviewed some stuff that we covered in the last tutorial, but we've also introduced how you can, at least a simple way for how you can start developing the entire form for the roofscape in this case, just in Grasshopper without having to model anything in Rhino. And when we do that, we get control back. So again, now that we're done, we can play around with some of these parameters, and everything downstream should update automatically. Okay, so this is one of the nice things about working in this way, is that if you have to make a change down the line that's still within the solution space that you've set up, you can very quickly do that without having to go back and remodel. And this is true for all the inputs that we've used. So I can make it taller, and all of those panels still remain planar. I was just playing with that one, so let's actually see, yeah, let's make these a little lower. We'll invert the entire thing. Yeah, we'll change the height of this a little bit. Yeah. So now we've got this, we've basically inverted the entire form. And nothing broke. It looks like the parametric model was able to handle those kinds of changes without a problem, and it still gives us the result, a working result, regardless. And you can also make changes to how many panels you have. So if you needed to add them to be far more dense in both directions, and it looks like this might need to be an even number in order to get that to work, just based on how I partitioned everything. So that's something to keep in mind. Again, because there's multiple ways to do what we did, sometimes the inputs will affect that result, so it's good to know what the limitations are. In this case, what we need to do is make sure that we're breaking it down in that direction with an even number. But that's not a problem. That's really not a huge issue. And if it had to be an odd number for whatever reason, then you would go back and you would change the way we're partitioning. Again, topics for further classes. But okay, I hope you had some fun here. Anyone that wants to start applying something like this to the fish form or to a shape of their own, obviously we'd love to see it. If not, please do finish up this file by taking this block, repurposing it to come out into the other side of the structure. Great, thanks.